Hello and welcome back to Refactoring Bitcoin. Today, I want to start implementing this C++ API that we have started declaring last time. And the first thing that what I want to do is I create a new directory, call it btck, and in this directory I create a new file, and this will be a CMake list.txt file. CMake lists.txt. And so this will become a new project where we will build the C++ API. So first thing I have to set is the minimum required version for CMake. I call CMake minimum required version, and I'm gonna set version 4.0. Then I have to name this project. I call project with the name btck. And now I want to add Bitcoin Core as a dependency. And I'm going to do that using a CMake module called fetch content. So I include the module, include fetch content. And now I'm going to call fetch content declare, because declaring fetching dependencies with fetch content is a two-step process. First we have to declare the dependency, and then in the second step we have to call make it to make it available, right? So fetch content declare, we call it Bitcoin, and we can set some options. We set the Git repository, needs to be uppercase, Git repository, and the Git repository is https://github.com/bitcoin/bitcoin.git. So now we have to call fetch content make available. So we call fetch content. This is make available, and it's called Bitcoin. Good. So what is here? What is a grammar error? Why? CMake minimum required looks correct. Anyway, try whether it works. I create a new directory, build C make dir build. Go into the directory build and run cmake ... What's wrong here? GitHub, oh, typo. Needs to be com, right? Run again. And now I see it's cloning the GitHub. It's cloning the the Bitcoin repository from GitHub. And while it's doing that, I'm gonna create all the other files. So I create a new file called include btck.hpp. Include like this. No. Include. Yes. Okay, and in this file I copy the contents of Bitcoin kernel.hpp like this. Okay. And I also create another include file. Let's say new file btck/primitives.hpp, and in this file I'm going to extract all the things that I've already converted to C++. So this stuff here, I want to extract this, so the block, but not the verify function. So I extract this and I put it into primitives.hpp. And in this file, I'm gonna just include btck slash primitives.hpp like this. I see that checking out was successful. Now it's configuring Bitcoin. And it's failed with an error, right? Because Captain Proto is not installed. But I can disable that using that option here. So, but I don't want to set it on the command line. I actually want to set it in my CMake list txt file. I set it here like this. Just set enable IPC off. And now I run again. And it was successful. Cool. Now I want to see whether I can build the Bitcoin kernel library. So I call make Bitcoin kernel. There's no rule to make that target. And the reason is, if I open C and CMake, I can see here the option build kernel lib is set to off. I could set it to on here, but I also want to set it in my source code. So I copy the name of this option and I set build kernel lib to on. And I rerun. I don't have to rerun CMake because it will rerun automatically. I just type make Bitcoin kernel. No, that works, sorry. So I run CMake. It was successful. Now I run make Bitcoin kernel and it looks like now it's building. So I can cancel that. Just wanted to make sure whether it's actually working. Let me continue with the API here. I can actually close this here. Good. The primitives. What's missing here? State function is not known. I'm gonna add an include guard like pragma once. And I'm gonna include the necessary headers for function, which is functional. And span is also missing, so I include span like this. And now it looks like all dependencies are satisfied. There are no squiggly lines anymore here. That looks good. Now I'm gonna create a source file. I create a new file and I call it, put it in the source directory, and I call it btck primitives.cpp. And in this file, I'm gonna include btck slash primitives.hpp. And I'm adding a library here. So I create a library, add library, and I call it btck. And I'm adding source files to the library. So I call target sources btck. And I'm gonna set the header files as public, and I define it as a file set which will be called headers. And I also define the base directories for the file set, which is base there's just my include directory, and the rest will be the files. So now I provide a list of files, which is include include btck.hpp and also include /btck/primitives.hpp, and my source file will be private, and this one is in src/btck primitives.cpp. And now I just format it nicely like this. Good. Let's see whether I can build it. I run make btck, and I have to rerun CMake. Now try again. It's building, right? But it tells me span is unknown. And the reason for that is that span is a C++20 feature, so I have to change the target compiler. I have to enable the C++20 compile feature. And I do that with the function target compile features for the target btck, and I set it public because it's in a header file. Okay, I call it cxx std20. Good, and if I now rebuild, yay, it's building a library. Cool. Now I can start implementing. I can close this file here. I have btck. I can also close this file, primitives. I want to start with the constructor for transaction. So I just put this here. So transaction, colon. So this is my definition of a constructor. Format it, and then just leave this empty, see whether it compiles. So yeah, it does. So now in the header file, you remember in the C API, we had those forward declarations of opaque types. We want to do the same in C++, but we want to do it, we want to have this opaque type in the private section of the transaction. So I turn this struct into a class, and all the stuff that we had previously is put into the public interface. And I add a private section, and in this private section, I just put a forward declaration of a struct. I call it implementation. Okay, format. And so I use a pointer to the implementation, and I call it pimple. What is this? Okay. So the pattern that the idiom that I'm using here, the pimple idiom, is when you have a pointer to an implementation in the private section of an opaque type. Okay. So that means in the constructor, I'm gonna allocate a implementation, which also means I have to deallocate it in the destructor. And I have to implement the copy constructor and copy assignment operator and move constructor, move consignment operator appropriately. But the interesting thing here is that all those member functions here, the ID and inputs and outputs and 2 bytes, since they are all marked const, the clients will not really observe a difference whether I make an actual copy of the data or just share it. Therefore, I can use a shared pointer here instead of the built-in one. say shared per, and I use a shared pointer to const because I don't want to allow any client to modify it, because otherwise, if I share and it's not const, then different clients will observe side effects when one of them performs a modification. But since the functions are all const, modification is not possible, and therefore the const here is just some extra safety for myself. Good. Now in the implementation, in the constructor, I initialize Pimple with std make shared of my implementation. I don't pass any arguments. Format it. Now does this compile? No. What's the problem? The problem is that it's an, yeah, of course, I haven't defined the struct yet. It's only the forward declaration. So what I need to do is I define the struct transaction colon implementation implementation. I just leave it empty for now. Now the squiggly line also disappeared, right? So that was a hint. So I run make and it's building. Cool. Okay. Back to the declaration. You see here that I don't have to provide a copy constructor or a destructor or assignment operator, because the default implementation will just do the right thing, because I'm using shared pointer to const here. Okay, but now I want to actually need to add something to the implementation struct here, right? It doesn't make sense to have just an empty struct. So I have to look, what did the actual implementation of the Bitcoin kernel do? I look at the transaction create, for example. Transaction create internally uses a C transaction. Okay. So if I jump to the definition of this C transaction, now I'm ending up in the definition of make shared. This is a stupid bug in the IDE, but here is another one. I can jump to that one. Okay, this is the one that I'm gonna wrap. Okay, so in which file is this? I just copy the path, the relative path of the file, and I want to include that here. Include without the source directory, like this. And I'm gonna, that's the wrong one. I want to wrap this here. So I call it tx, put a member of this transaction in my struct. And if I now want to compile this, I see in a squiggly line, the include directory is not found because I did not add the dependency yet. So what I have to do is call target link libraries, btck, and it's a private dependency. So I call private, and the target is Bitcoin kernel. And if I build now, I see it's building the kernel, because now it's a dependency. So it starts building the kernel, and afterwards it builds my library. And I can see what it actually builds. Yeah, it builds crypto and CRC32 and level.db and some stuff from secp, and then here files from the kernel directory, and I'll wait a bit until it's finished. In the meantime, I can copy this other stuff, right? We had this Bitcoin kernel dot file. Just copy that. And I also want to put it here in my new directory. Put it in the docs directory. Doc slash, call it architecture. Dot, put this here. Is it still building? I could have built with multiple process in parallel, but I just wanted to show the output here. But it's finished. It's nearly finished. Good. But it does not find the header file yet, even though I added it as a dependency. So this is a bug actually in Bitcoin, because usually when you define, like we did here, a library should always declare its public header files as a dependency. Bitcoin Core does not do that yet, so I have to add a hack. So what I do is from fetch content, I have to call fetch content. It's called get properties. So I have to get the source directory property, and I have to add it as an include directory to my library. So the name of the dependency is called Bitcoin, and the property that I want to get is called source dir. And I want to store that in a variable called Bitcoin underscore source dir. And now I can add this, I can use this variable here, and I call target link libraries, target include directories of my BTCK library. I also make it private. And what I add is Bitcoin source dir slash source. And if I now try to rebuild, now it's finding the include directory, but I get a bunch of other errors. Scroll up, what's wrong? I get a typedef redefinition because this TXID is used in Bitcoin Core internally in the global namespace. And I've also haven't introduced a custom namespace yet. So this is what I want to do next. In my primitives file, I just define a namespace, BTCK, and I close it at the end of the file. And I have to do the same thing in my source directory. So namespace, BTCK, opening brace, and I have to close the brace at the end of the file. And if I build now, it cannot still get errors because it cannot construct my implementation, because apparently this C transaction here does not have a default constructor. So let's see what is done in the C++ implementation of the C interface. Here I have this function transaction create. I have to do something similar. So I copy that and I put it here. So, and what I want to do is I call a function, call it parse transaction, right? Because it's parsing from this raw bytes. Parse transaction. I don't pass a pointer to void with a size, but I actually pass this span of bytes. Okay. And now I can delete this boilerplate here. So this will never be a null pointer. So this condition here can be removed. And I can also remove the boilerplate for this try catch block. And this data stream here is initialized with a span, which is created here from the pointer and the length. But I already have a span, so I just initialize it with my span like this. This data stream is not known, okay? So I can search where is it defined, and I copy the path of this directory, and I also want to include it here. Without the source directory. So it's just streams.h. Interesting. No data stream is available, but I actually prefer to have the types on the right. So I want to initialize the variable like this. So I extract that, write it like this. And this wrapping here can also be removed. I just return, no, I actually don't want to return a shared pointer because I'm calling make shared in my constructor. I just want to return the thing that is created here. So I return a transaction and I pass the rest as constructor arguments. And I use automatic type deduction. So my pass transaction is now looking like this, and I format. Now I just call this function and pass the result as the argument to make shared. So in here we pass the span of bytes. Okay. I cannot inline the parse transaction function completely here because as you see here, this constructor, if you go to the definition of the constructor, it seems to be this one here that takes a stream. You see the stream here is passed by reference to an L value. So the stream needs to be an L value. And if I so I need to have this local variable here. And I cannot have a local variable in this initializer list directly. So therefore, I need to have this helper function. Now I can build, and it looks like it's building fine. Cool. Now, in order to test this, I need to have I just want to add a test, right? So I create a new file, call it test slash call it transaction.cpp. And in my CMake list.txt file, I create an executable. I call add executable btck test. And I add the source file. Source, no, it's test slash transaction.cpp. Nicely formatting. Okay, and this one, of course, depends on BTCK, so I call target include directories BTCK test, and it's private. It's a private dependency BTCK. And in the source code, I want to include the interface. It's called btck slash primitives.hpp. And I want to have a main function. Main. Okay. Does that build? I call make btck test. Nope, I have to reconfigure. Now it's building, but it doesn't find the header file. BTCK primitives, why not? Target include direct, that's target include directories. I need to link, of course. Target link libraries. And if I now rerun, now it's building the executable. Can I run it? BTCK test doesn't do anything because my main function is empty. Okay. But where is the source code? Here. What I want to do, I want to create a transaction. Call, I need a buffer. I need some data, some test data. So I copy test data from somewhere else. Okay, put this transaction data here. Okay, and now in my main function, I can initialize it. So this is an array of uint8, and I can turn the array into a span by calling span and just passing the data here. Data, and if I pass that span to the function as bytes, that will give me a span of bytes because the other one was a span of uint8. And that span of bytes can now be passed to the constructor of my transaction, btck : transaction. And I pass that like this, and I store that into a variable called tx, and I format it, and now it looks like this. Okay. Now if I build and run, my test runs, right? So apparently it invokes the constructor of the transaction and it passes the span of bytes. But okay, what can I do with it? Okay, so my transaction here, so I haven't implemented any of the other functions yet. I could quickly implement the ID function. I could also implement the inputs function, but because of this range here, this requires a longer explanation, and I want to do that in a separate video. And even if I implement this ID function here, this txid is just an array of bytes, and we don't have a nice way to print the span of bytes, so I cannot really make it do anything. So we'll also do it in a separate video to actually implement something that where we can verify that the transaction is initialized correctly. For now, I think this is a rather nice start. So we have our header files, we have a source file, we have test, we have set up a CMake project with a dependency, right? It's cloning the Bitcoin source code from GitHub. It's building the dependency. It's implementing the a single function. I think that's a very good start. And we can then in separate videos implement all the other stuff. Well, that was it for today. Thank you for watching, and make sure to subscribe, like this video, show it to your friends and family. Make sure your parents subscribe and your kids subscribe and everybody else that you know. Thanks for watching, and see you next time. Bye.